Here we're going to introduce another type of function known as a rational function. When you say the term rational number, that means fraction, something that can be expressed as a fraction. So a rational function is one where you have fractions and the variables appear in the denominator of those fractions. So we're being asked to solve this, right? And so we know the drill here. If we're solving f of x equals 0, then we're plugging 0 in where we see f of x. And we've got to figure out how to solve this. Okay. Now the first thing we notice when we look at this is that we don't really care for the fact that there's x's in the bottom of the fraction, right? We don't really know how to get x by itself if it's in the bottom. So our first order of business is to get the x's out of the bottom of the fraction. How do we do that? Well, if we multiply by the least common denominator of these two fractions here, then they would cancel out in each term. Then the bottoms would cancel out in each term. All right, so what I'm suggesting is that we do this. We take x times x plus 1, okay? Because if you want the least common denominator of these two, you take their product to find the least common denominator. And what I'd just remind you of here is, when else have you worked with common denominators, when you add fractions? So let's take like 1/5 and 1/6, right? So you would say, I need a number that both 5 and 6 can fit into. Well, anytime 5 and 6 have nothing in common with one another, you can always find the least common denominator by multiplying by the other one. So in this case, of course, it's 30 is the least common denominator, but we just got it by multiplying those together. So I'm doing the same thing here, right? I don't know what these numbers actually are, but I do know if I take the product, I'll get a common denominator. All right, so I multiply that. Now, of course, anytime you're working with an equation, whatever you do to the right side, you must also do to the left side, correct? So what we can't forget is to then go ahead and do this, right? Multiply on both sides. So on the left, the nice thing is since there's a 0 over there, it's still 0. But over here on the right, we have to go through the work of distributing this to both terms. So I encourage you not to take too many shortcuts here. So we know that this x times x plus 1 is really that over 1 if you want to write it as a fraction. So top times top, bottom times bottom. So we end up with this in the first term. And we end up with this in the second term. But of course, here's where the purpose of this multiplying by the LCD on both sides comes in. I get to cancel out the bottom of both of those fractions. Okay, so this act here is what we refer to as clearing the fractions by multiplying. And we're careful to say on both sides of the equation by the LCD, the least common denominator. So I'm left here with 0 equals 6 times x plus 1 minus 4x. All right, but I can go ahead and distribute this 6 through to both terms. 6x plus 6 minus 4x. So 0, combine my like terms gives me 2x plus 6. So if I subtract 6 from both sides, we get negative 6 is 2x. And then dividing by 2 finishes the job here. So negative 3 is x. All right, now, like we talked about when we were looking at the square root equations, it's good to plug back in and make sure the left side equals the right side. If you don't want to take the time to do that, here's the thing you at least need to make sure you do is you need to check your answer to make sure that it doesn't cause problems in the original function, or in the original equation, I should say, because we don't, we know we can't divide by 0. So if this number that we pop out with causes us to divide by 0, then it's not a solution. But you can see -3 is fine for this fraction and it's fine for that fraction. So that in fact is our solution. All right, this next example that's below it is a little harder, I would say. But I still think would be good, especially if you're fresh out of Math 95 or another intermediate algebra class. You might remember exactly how to go about this. So give this one a try yourself before continuing to watch the video. All right, so we should have started here with 0 in for g of x is equal to this, right? Now, in the last example, what we did was we multiplied the two denominators together to find our least common denominator. Now we have 3 different denominators, right? So what do we do here? Well, if you multiply all of them together, it can work, okay? But you're going to end up with something much more complicated than is necessary. So one of the things I would remind you of is, and to kind of use the same problem we did earlier, so 1/5 minus 1/6 plus 1/30. What if that was what I was trying to add up? If I multiplied 5, 6, and 30, that would give me a common denominator, but it would be a huge common denominator, right? Way larger than we need. So in this case, what we would want to do is recognize that, 30 is 5 times 6, right? So our common denominator can still just be 30, right? And here, just multiply by 6 on top, multiply by 5 on top. So what we want to watch out for is, yes, technically we can multiply all the bottoms of the fractions by each other to get a common denominator, but that might make things way too hard. Okay, now what did I do here with 30 to notice that it was just made out of 5 and 6 anyway? Well, I factored it, right? So one of the things you need to do with your variable expressions is if anything in the bottom of a fraction can be factored, you need to do that. And I chose this one here because this is a particular look that you're going to see a lot. And so we should take the time to name it. Notice that it's a quadratic with no middle term, okay? And this 4 here is a perfect square. So what we say is this is a difference of squares. And that always factors in to this. So x minus the square root of this number and x plus the square root of this number. And you can see why, because when you do outside plus inside, they'll always zero out. But notice what else we did. We noticed that we have the product of these two is x squared minus 4, just like the product of 5 and 6 was 30. So now I know that I'm not going to multiply by the product of all of them. What I'm going to do is I'm just going to multiply by, I think I'll rewrite this. I'm just going to multiply by x minus 2 times x plus 2 on both sides. But that, of course, means I have to do a lot of distributing here. All right, so nicely we have still 0 on the left. For the first term here, though, I'm going to have this. For the second term, we'll have this. And, you know, if you get real slick at these, or you already are from some of your past classes, you know, maybe you can skip a step here or there. I'm, of course, being a little bit more careful about how many steps I show since I'm doing this on video, and I want to make sure that everything's real clear for everybody. All right, but you get all that nice cancellation, right? So let's see what survived all that canceling. Looks like it was 3 and x plus 2 multiplied together. It was 2 and x minus 2 multiplied together, and then just plain old 13 over here on the right. And then I do some distributing, right? So 0 is 3x plus 6. And then one thing to always remember, this is just such an easy trap to fall into. As I distribute through, make sure this minus sign in front of the 2 goes with it. So negative 2 times x is negative 2x or minus 2x. Negative 2 times negative 2 is positive or plus 4. So don't forget to carry that negative through. And if we combine like terms, 3x minus 2x, that's just x. 6 plus 4 minus 13 is minus 3. So it looks like x equals 3. So by coincidence, same answer as the last problem. Totally a coincidence. And we want to make sure that didn't cause us to divide by 0. So if I put a 3 in here, no problem. If I put a 3 in here, no problem. And if I put a 3 there, also no problem. It's not going to give us a 0 in the bottom of any of those fractions. All right. So on the last problem, if you didn't try that one on your own, or if you didn't, or if you did and it just didn't go well, then I would encourage you especially to pause this one and try this one on your own. I suggest it for everybody, but especially if you didn't do the last one. All right, so give this one a try. All right, so coming back from you pausing here, this time they're asking us to let f of t be equal to 4. All right, so I'm plugging 4 in here for f of t, and that's got to equal 480 over t minus 20 minus 480 over t. All right, so as I look at t minus 20 and t, I can't factor either one of those, right? And they're definitely different things. They both have t's in them, but one is not a multiple of another or anything like that. So that's one of the situations where the LCD is just the product of the two bottoms of the fractions. So I can just make a little note here that my LCD is t times t minus 20. So on the left side, t times t minus 20 times 4. And then on the right side, same thing. All right, so on the left side here, we can do some distributing, right? So 4t squared minus 80t. And then here, 480t times t minus 20 divided by t minus 20. And then minus 480t times t minus 20 over t. And as in those last couple of problems, we definitely get some nice cancellation here. So let's see what we're left with. We have 4t squared minus 80t equals 480t minus, all right, now I'm going to distribute right here, right? I had these t's cancel, so I know that minus 480's got to go to both of these, right? So we're going to have minus 480t. Look at that, those cancel. That's kind of nice. And then 480 times 20, that's going to give me plus 9,600, right? Plus because it's negative 480 times negative 20. All right, so of course these two just zap each other. So what do we have here? We have a quadratic, right? And generally with quadratics, what we want to do is get one side equal to 0, right? So 4t squared minus 80t minus 9,600. Now, could we apply the quadratic formula right away to this problem? Absolutely, right? We could definitely do that. But one thing you want to do is look for just easy things that you can do that will make the numbers more friendly. So I look at 4, 80, and 9,600, and I notice they're easily all divisible by 4, right? So what I'm going to do here is I'm going to go over here, and I'm just going to factor a 4 out. So I end up with t squared minus 20t minus 2,400 is equal to 0. All right, so I know that this 4 doesn't really contribute to the solution at all. In fact, if you wanted to, you could divide by 4 on both sides, right? And you're left with just t squared minus 20t minus 2,400. So what we have is a quadratic here where a is equal to 1, right? B equals negative 20, and C equals negative 2,400. All right. Let's see here. Yeah. So, sorry, I thought I made a little error there, so I was making sure that I didn't. All right, so now when we set up our quadratic formula, t equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 2,400. And you can see we've got some big numbers here for sure, right? But they would have been even bigger if I hadn't factored that 4 out. So t is equal to 20 plus or minus the square root of, so what do we have? We have 400 plus, if you do this arithmetic here, you're going to have 9,600, all divided by 2. But that gives you t equals 20 plus or minus, it's the square root of 10,000 divided by 2. But that's 20 plus or minus this 100, excuse me, because 100 times 100 is 10,000. So that gives me two different solutions here, 20 plus 100 over 2, which is going to give me 60, and then 20 minus 100 over 2, which is going to give me, oh boy, I've run out of room, I'm sorry, negative 40. Okay, so down here we'll write it cleanly, so we get t equals 60 and negative 40. Now, we double check, make sure 60 and negative 40 don't get us into trouble, but if you look back at the original, they don't cause us to divide by 0, so we're in good shape. All right, so now, last example here. We got kind of a funnier looking equation. So what happens when we have equations that have, or functions that have fractional exponents? This one is a topic that you would definitely have seen in an intermediate algebra class. However, it's definitely possible you didn't go into it in tons of depth, so I understand if this seems pretty new to you. So let's first of all remember what a fractional exponent actually means. So if I take a variable and I raise it to a fraction, let's say it's m over n, the top number is the power that you're going to put on the x, so I'll say x to the m, and then the bottom number is the root. You can also say it the other way. You could say it's the nth root of x, and you can raise that to the m power. Okay? So that's how we define that. So as long as you have a reduced fraction here, this is how this definition actually works. So as I'm looking at this formula here, this little 3 I know means cube root. This little 2 in this case means then you're squaring the x. Okay, in this case you're just raising it to the 1. So when I have g of 8 is equal to, well, I'm going to put 8 in for everywhere I see an x. Okay. Now, all I have to remember now is that the 3 means take the cube root, and the 1 means raise it to the first power, right? So we know that the cube root of 8 is 2 from our work earlier with the cube root graph. So we can change that to a 2. So kind of doing this in reverse order, aren't I? But 8 to the 1/3 becomes 2. And then this one, I'm going to square it afterwards, right? So if 8 to the 1/3 is 2, then squaring it becomes 4. So I'm going to put a 4 right there. And so, of course, then we get 4 plus 14. So we get an answer of 18. So when x equals 8, the output of this function is 18. All right, how about solving this thing, though? Okay. Negative 12 is my f of my, oh, sorry, a little bit of notational problem here. This should say g of x, okay, instead of f of x. So g of x equals negative 12. So I plug negative 12 in for g, and then we have x to the 2/3 plus 7x to the 1/3. All right, so we have this equation we've got to solve. And I want you to pause and try to problem solve this. This is not an easy problem by any stretch, but see if you can come up with an idea for it. Now, I would not fault you one little bit if you just stared at this thing for a little while and didn't really come up with ideas, because it's weird and it's probably unlike most things you've done. But here's what you do in mathematics, right? When you encounter something that is new, you might ask yourself, what about it is similar to something I do know? And the thing that I notice here is that I have a term with a square, with a 2 in the exponent, and I have a term with a 1 in the exponent, and I have a constant term. So that makes me kind of think about solving a quadratic equation. All right, so if I were solving a quadratic equation, I know my first step would be to get both sides, or get one side equal to 0, right? So get all the terms on one side. Okay. And then what would I do next? Well, the two techniques we've talked about is we would either do the quadratic formula or we would factor. Okay. We've done a couple in a row where we've done the quadratic formula automatically. Let's just see about factoring. Okay. We've got these 3 terms. So if factoring works, first of all, I can't take something out of each term. So I can't factor in that sense. But, you know, maybe I can factor like this. All right, so let's remind ourselves of what needs to happen. This is the first times the first, right? So if you want to create x to the 2/3 by multiplying 2 things, what would those 2 things have to be? Well, the answer is they'd have to be x to the 1/3, right? Because remember from our exponent rules that when you multiply like bases, you add the exponents, right? So that's how you're going to produce this x to the 2/3, is by adding the exponents 1/3 and 1/3. And that's good because the middle term needs to have x to the 1/3, so you're going to have that. And then let's also remember what happens here, right? So 12, you need to make that by multiplying the last times the last. Well, this is positive, so the signs need to be the same. And since the middle term is also positive, I'm thinking they both have to be positive, so I'm going to put a plus and a plus here. And then let's think about what multiplies to make 12, which also adds to make 7. Well, that would be 3 and 4. So I'm going to put a 3 here and a 4 here. And let's check. 4 times x to the 1/3, that's our outside. 3 times x to the 1/3 is our inside. If we add them together, we make 7x to the 1/3. So that is a correct factorization. Once we have that, we can then set each one equal to 0. So I have x to the 1/3 equals -3. All right. Now let's think about this for a moment. What do we know? 1/3 is really just a cube root, right? So to get rid of a cube root, we would cube, right? Or another way to think of it is, think of it as what power should I raise to in order to make the exponent go away? Well, remember we have a rule that says x to the m raised to the nth power is x to the m times n. So you multiply these powers. So what do you multiply 1/3 by to make 1? You multiply it by 3. So we have x equals -3 to the 3rd would be -27. And we can do the same thing here. X to the 1/3 plus 4 equals 0. Subtract 4 from both sides. But I can raise both sides to the 3rd power. So x equals -64. So those are my two solutions in trying to solve g of x equals -12.